Good afternoon, YouTubers. Hi, it's the Valvanist. Just bit of interest for you on the vintage audio ephemera topic. What have we got here today then? I thought I'd show you this. It's just come in. This is a Windsor output power meter from the 50s. An old piece of test gear. And what does it do? Measures signal power. We've got a readout in milliwatts here. We can set a range, so we can adjust what that range means. Input impedance, so you've got to select what impedance the input here sees, and here's your impedance selector and impedance multiplier, so that you can set it up correctly. So why would I want this? What use is it to me? Well, I can stick an amp into it on the speaker out. I can set up the impedance to match the speaker it's expecting, set up the decibels reader, whether it's going to be a 100 watt amp or a 5 watt amp, and get a readout, so it'll act as a dummy load while I'm testing, and it'll tell me what the power output is. Might need a bit of calibration or a cleanup, but we'll find out. Let's have a look. First thing first, we'll just have a quick look to see whether it's a complete mess or whether it's basically sound. The controls feel good. The needle is moving, it's not rusted solid, so that's all good. So what have we got here? There we go. So, not a great deal to these. It's basically setting up a bunch of ranges on the potentiometers to sort of calibrate it for the input, and a whacking great transformer to accept the load. And that looks okay. It's waxed. I don't think that's leakage. I think that's just an old waxed transformer. 20 amp, so it can certainly take a decent size amp going into it. This is a calibration for the scales, so that's a variable resistor along there. You adjust the scale by moving that along there to calibrate it, and that's your meter at the back there. So not a great deal to it. It looks fairly decent, so I think inside, with a bit of luck, it might just need a bit of clean up, clean these contacts, because these are a very accurate, well, hopefully they still are accurate resistors. So you've got 20 ohm, 19 ohm, 21 ohm calibrated resistors, high spec resistors basically. And so we don't want to have a load of crud on the top here, adding resistance on top of those, so we give those a clean, and yeah, we'll have to give it a test. But it's looking okay. It looks like somebody's been in, done a bit of rewiring there, maybe a bit of a repair up here, but yeah, looks good. I'll give it a bit of a clean up, and then maybe we can actually see what the signals are doing. I've got some O grade sandpaper. That should just bring these up. We don't really want to see me do all that, but we'll come back in a minute. All right, catch you in a sec. Okay, so the sandpaper's just a little bit is bringing up the contacts nicely. A bit of wire brush where I can't quite get in with the sandpaper, and it's looking much cleaner. I can move that round to get to and a bit of isopropyl alcohol. It's, yep, it's coming up well. Clean off any of the grease. There's some grease on the axles of these, which has leaked a little bit. So get rid of some of that, get these nice and clean. And I don't know if you can see any of this, but it's not very exciting. But anyway, so we are getting this cleaned up so that the contacts are low resistance, so that it's hopefully more accurate. I mean, I'm not expecting this to be a high precision, but if it just gives, I can plug in and I can A, have a load, and B, get an idea of how much power I'm putting out. It's going to be a big boon for setting up amps, putting new valves in, rebiasing, that sort of thing, bringing amps up. So there's a thought. I wonder if I can take a tap off of the transformer, so I could have it as a load and direct inject box, like an aux box type thing, but 1950s style. I'll have to think about that. That would be quite cool. Right, well, there's not a lot else going on here. I mean, there's the calibration, which can be done with here, but I'll need to get a measured output from, measure the voltage out on my oscilloscope and do a manual bit of maths to work out what the output is, and then I can adjust the coil to hopefully have a calibrated reading. All right, well, I'll put this back together and then maybe we'll see where we're at. Okay, so I've got my advanced audio signal generator set up. I can adjust the output here, frequency here, and so we want to test the output, if that registers on the meter. Let's have a look. I thought I'd just quickly test. So this is the impedance that's seen through the transformer. So it's not directly coupled to the input, it's through the transformer, but on the output of the transformer we can see the resistance is selected nicely, and a range multiplier is changing that overall resistance as well. So yeah, it all seems to be functioning, so that's a good start. Okay, it's time to do a bit of a check to see if it's functioning and seeing if it's what it's reading. So signal generator, we're creating a sine wave, and here it is. That's the sine wave we're generating, and we are checking its RMS, its peak-to-peak voltage. So we've got, well, I can wiggle that up. I get 16 volts-ish. Okay, so we got 16 volts. We need to get the RMS, so divide by 1.414, and we need to square it, and then we need to divide by the resistance. So our impedance, our load is 600 ohms, and the answer is 213 milliwatts. 213 milliwatts. So we've set this up to times 10 factor. We've got times 10 times 60, so that's 60 times 10, that's our 600 ohms load. And we've got a factor of 10 gain on the scale, and we are measuring 21 milliwatts times 10, 210 milliwatts. I think that's good enough for me. Fantastic. So yeah, really pleased with that. So I can set this to 8 ohms, connect the amp output, and check its power outputs. So that's a result. So on this quick test, it's working really well. Excellent. Okay, now to do a test with an amp. We're plugged into the speaker out of the amplifier. We've got our signal generator for our input, and this is the oscilloscopes on the output. And we have the AC voltage. So we start to ramp up the output, and we get to where it starts to flatten off. It's the start of the distortion, so we sort of go to the edge of distortion. So about there, about there. So we're on about yeah, let's call it 7 volts, and we are on just over about 3.2, let's call that. And if you take 7 volts divided by 1.414, square it, and divide by the speaker ohmage, which we're on 80 divided by 10, so it's 8 ohms, and we're on 30.1 times 100, so that's 30 millivolts. 30 milliwatts times 100 is 3 watts. So that's what we're getting from the meter. So yeah, 7 done the maths on that, it comes out at about 3.1. We've got about 3.1 there, so that's still agreeing at this sort of higher output level, which is great. What I'm slightly unsure of though is this amp should, it's 2.6v6s, should be giving us more like 12 watts, but that's something I need to look at. It's possible that the impedance that is being set here is not the same as the speaker impedance, but something I've got to look at. But it's certainly acting as a dummy load and giving me a good indication of the power going into it, so I can monitor that and watch it as I bring the volume up and down, so I can see it on the waveform there, and I can see it on the meter here. So that's going to be really handy for me. Excellent. So that's a result in my book. Thanks for watching, and if you've any questions or thoughts or input, stick it in the comments. Cheers.